Hi everyone, and thanks for coming to this presentation. I'm very happy to be with you today. It's my first time in Krakow, and it's a great pleasure to speak about Core Web Vitals, and especially to give you some advice and tips to optimize the Core Web Vitals of your application. So, before doing these talks, I have some question for you. Who is in this room a web developer? Most of you. And who's here of Core Web Vitals before this talk? 2 persons. Okay, great. So, first, let me introduce myself. My name is Nicolas Frizzarin. I'm a Google developer expert in web technologies and Angular. I'm also an OpenJS Foundation member, and I worked as a developer advocate and engineering manager at Sphere. Just a few words about my company. Sphere is a consulting company based in France, Luxembourg, and Belgium. So if you have the idea to come in this country, don't hesitate to contact me to have more information. So, what's the plan today? What will we see in these talks? First, why users are unhappy to use your application, even if your application works very well. Then we will see what really are Core Web Vitals to focus on each metrics that compose the Core Web Vitals. So the first metrics will be the LCP, largest contentful panes. The second one will be the cumul layout shift, CLS. Third one, the FID, first input DD metrics. And the last one, which is still in pending statue and not totally integrated into the Core Web Vitals, is the INP metrics, the interaction to next paint. So I suppose you guessed it, but this talk is about web performance, and to be more specific, this talk is about web performance that impacts in a negative way the user experience. So, why users are unhappy to use my application? My application seems working very well. All the data are displayed, all the data are correct, the unit test pass and the integration test pass. So, what's the problem with my application? The problem is, if you ask to your user why they don't like to use your application, generally the answers are, I don't know, but when I open your application, it takes too much time to display something to the screen. Second answer are generally, I have a blinking screen. Some elements pop in a randomly way in my screen. And the last one is, your application is totally buggy. But this doesn't make sense because all the integration pass. In fact, when the user clicks on the button, the result of this interaction takes too much time to be displayed. So, based on this information, we can identify 3 important information. The first one is the low speed of your application. The first page takes too much time to be rendered. Second information is you have a blinking screen. Some pieces of your page are loaded asynchronously and they pop on the screen randomly. And finally, the user interaction takes too much time. So the feedback of these interactions take too much time to arrive to the users. And in 2023, this is a bad experience because at this perfect moment, the user is totally frustrated and can go easily to the competitor, because in 2023, it's a lot of applications do the same business. Let's take an example from streaming music. Who use in this room Spotify? Okay, who use YouTube Music? And Apple Music? Okay, so all these applications do the same job. Okay, so if you don't like Spotify, it's easy to go to YouTube Music. It's just really an abandonment. Okay, So generally, to keep users, we change color, contrast, fonts, image, and position of elements. But all these things have an impact on the user interface and not on the user experience. But having a great user interface, it's important because today, users like to have a beautiful application, well designed. If you want to improve user experience, you have to improve the times before the user sees directly something on the screen or stops making the user reading his losing focus, or improve the times to have the feedback of the user interactions. If you do that, you have an application that respects the user experience. And nowadays, having an application which responds immediately, displays something immediately, and where the user don't lose his reading focus, it's very important. So in conclusion, it seems that our application delivers a bad user experience. And guess why? User experience is very complicated to improve because the user experience depends mainly on the users, and each user has not the same feelings. So to improve the user experience, we have to find a way to characterize this into a specific problems. In this case, user experience will be characterized in a performance problems because as a web developers, it's quite easy to solve performance problems. Then we must find a way to help developer to catch these issues easier and earlier in the process of the development of your application. And then we must find a way to summarize into a specific category. Because there is a lot of web performance problems, but few of them impact the user experience. So that's why in 2020, Google announced to have the volunteer to integrate 3 new metrics into all these performance and dev tools. And in 2021, these 3 metrics are integrated under the name of Core Web Vitals. So nowadays, it's very important to respect the Core Web Vitals because Core Web Vitals have a huge impact on the indexation in the Google search engine of your application. So in other words, an application that respects the Core Web Vitals have a better indexation in the Google search engine than an application that doesn't respect the Core Web Vitals. So to summarize, Core Web Vitals is an initiative from Google that aims to have metrics on the performance of web application that represents the user experience. So let's take the following application as an example. So I have an application that is deployed through Heroku, Supabase, Firebase, any providers. In fact, providers have no impact on the user experience, okay? But my application have some huge performance issues. First, my first page takes too much time to be rendered. Then I have some iframe that pop on the screen randomly and in an asynchronous way. And finally, the results of user interaction takes too much time to be displayed to the users. So all these issues have a significant impact in the following metrics of the Core Web Vitals. First one will be the LCP, largest contentful paints. Second one will be the CLS, Cumul Layout Shift. And the last one will be the FID, First Input Delay. So we know what really are Core Web Vitals now. It's true, but we don't know how to retrieve them. And this is the most important part of this talk. It exists 2 ways to retrieve the user experience metrics. The first way is by the field. So all field tools provide the real-world data that comes from users in the field. This measurement is called real user monitoring, RUM, and the data it collects is called field data. Okay, it's a big definition, it's true, but in other words, by the field tool provide you real user experience metrics. Okay? But as I said in these talks, we must find a way to retrieve the user experience earlier during the process of the development of our application. It's a very bad idea to go in production without user experience metrics. So the second way to retrieve the user experience is by labs. And lab tools provide the data on how potential users may experience a website and are used for debugging by developers. The data provided by lab tools are called lab data. Also, it's a big definition, but in other words, lab tools give you the possibility to emulate the user experience. So in other words, lab tools are just dev tools present to help you to emulate the user experience. So all the field tools are created by Google. So there are Chrome user experience, PageSpeed Inside, Search Console, and the Core Web Vitals extensions. All these tools let you to retrieve easily the LCP, CLS, and FID metrics. It exists another tool, which is a JavaScript library. This is my favorite JavaScript library with Core Web Vitals. It's webvitals.js, and this library gives you, thanks to helper function, to retrieve easily the Core Web Vitals extension, metrics in production. And this library, thanks to callback systems, give you the possibility to make your own business logic with these metrics. So maybe you want to retrieve these metrics and send it to your own database, maybe to have some statistics after. Lab tools. Lab tools are prisons for developers, okay? Lab tools let you to emulate the user experience. So lab tools are Chrome DevTools and Lighthouse. All these tools let you to retrieve LCP and CLS metrics, but they can't retrieve the FID, first input daily metrics. Is anyone in this room have an idea why field lab tools can't retrieve the FID? No? The FID is the first input daily. So to retrieve these metrics, the users have to interact with your page. And emulate the user interaction is quite complicated. So that's why lab tools can't retrieve the FID. They can retrieve the blocking times. The blocking time can be assimilated to the FID matrix for a first page reload. So lab tools and field tools are not the opposite. They're friends. They complementary each other. Because user experience depends on the user, which depends on three following important points. First, the user device capabilities. Not everybody can buy the last device or the last iPhone. Technology is constantly evolving. The RAM and the CPU of our device are bigger, and the application we made are following this technology. So it's totally normal if the render of the first page of your application is faster on the last iPhone than on the very first iPhone. Then the following point is network condition. We are not all equal when it comes to internet condition. In Europe, network condition is pretty good. We have fiber, Wi-Fi, 5G, 4G, so conditions are well optimized. But in other parts of this world, some people have a bad network condition, or they have no network condition. But for this kind of people, your application will never display, in fact. But what is important to understand is here, when we create new web application, generally we create applications thanks to Vue.js, Angular, or React frameworks. Okay? But all these frameworks are a client-side rendering frameworks. And what is a client-side rendering application? It's just to retrieve the main.javascript files and create all the application in the browser using the document object model. So imagine that you have a huge JavaScript main file. It will take a lot of time to download this file with bad network conditions. And maybe for users that have a bad network condition, your applications will never display because the downloading will take a lot of time. And the last point is the kind of interaction of our device. Not everybody uses the device as all people. Okay, so generally when we use our device, we open an application, but we never close it. So at the end of the day, we have a lot of applications that run in background on our device, right? How works a CPU? A CPU allocates a little part for each application that run in the background. So it's easy to understand now if you open your application in a device that have no application that run in the background, the allocated part to this application will be bigger than on a device that have a lot of applications that run on the background, right? So now let's go to the LCP. The largest contentful paint matrix represents how quickly the main contents of a web page is loaded. In other words, the LCP represents the time that takes the browser to render the biggest block text of your application or the largest image. So if the LCP matrix is less than 2.5 seconds, your LCP score is good. Between 2.5 seconds and 4 seconds, your LCP score needs improvements. But don't worry, it's nothing, okay? Just a few adjustments. But above 4 seconds, the LCP score is very bad and all your applications need to be reviewed, front-end side and maybe also the back-end side. So, as I said, the LCP represents the times that takes the browser to render the biggest block text of your application or the largest image. So where to start for debugging LCP problems? Quite easy, it's on the initial HTML documents. Let's say for this talk, the initial HTML documents will be the index.html file. When you find it on your application or on your project, sorry, 3 important questions to ask yourself. The first one will be, what does these documents need? Second one is, how is needed? And finally, what is the size of the external parts? When you have answered to all these questions, second step is to retrieve the LCP resource and ask yourself the following question. How are these loaded? And are these necessary when the app starts? Let's take a little bit example. Who use Angular here? Okay, and who use Angular material? Okay, when you load Angular material, you load all the style of Angular material, and maybe all this style is now needed for the first page. So at this moment, it will be a good idea to split this content. So in this schema, I will explain you how to retrieve the LCP, how the LCP is calculated. So in this schema, you can see 4 different colors. The first one is the blue. The blue corresponds to the initial HTML documents, alias index.html file. In violet are the style sheets. And in green, the LCP resource, which is here, an image, just an image. And in yellow, we have the JavaScript file. So first, the browsers download the initial HTML document. When this index HTML document is totally downloaded, if the initial documents have some style sheets, the browser downloads the style sheet. When the downloading is finished, if the style sheet depends on an image, which is here the LCP resource, your browsers download the LCP resource in parallel of downloading JavaScript file, parsing JavaScript file, and executing it. When all this stuff is done, and the biggest block text or the largest image is rendering, you obtain the LCP score. So there are a lot of things that impact the LCP. And that's why the LCP problem is a complex problem. And as all complex problems, it's a good idea to split into smaller and easier problems. So the split is the following. First problem will be the time to first byte. The second problem will be the resource load delay. Third problem, the resource load time. And the final problem is element render delay. On a scale time, this problem represents respectively 40%, 10%, 10%, and 40%. But all these measure is purely theoretic. Okay? All these measures must respect your application. Depends on your application and depends on your needs and architecture. So maybe in your case, the time to first bytes represent just 10%. So at this moment, you have 30% to dispatch for other problems, right? And so at this moment, the time to first bytes can represent 10%, the resource load delay can represent 20%, resource load time can represent 20%, and element render delay can represent 50%. Okay? So if we apply this split on the previous schema, we obtain this schema. So first, we have the time to first byte. The time to first byte is the time that takes the browser to retrieve the first bytes of your initial HTML documents. The resource load delay represents the time that takes the browser to download all the HTML file, parse the initial HTML documents, and download all the style sheets. The resource load time represents the time that takes the browser to download all your LCP resources, and the element render delay can represent the time that takes the browser to eventually download all the JavaScript file, parse it, and execute it to render the biggest block text or the largest image. So how to improve this? Here's my tips. First, preload. Preload resource like style sheet or image. For this, it's quite easy. You have just to use the real attributes. Then, defer script. Lazy load all the script. Lazy load all what is not needed for the first render of your application. And you can use for that async and defer attributes. Then you can give priority now. Fetch in priority resources which are needed thanks to the fetch attribute attribute. And finally, split your contents. Don't load unused code. Take liked format for image. If you apply that, you optimize all the problems we've seen. Okay? So thanks to preloading, now when the browser discovers the dependency of the initial HTML documents, immediately it downloads the dependency. So here it downloads the style sheet and it downloads the LCP resource. And that's why style sheets and LCP resource are downloaded in parallel. Okay? What is important to understand is you have to improve all the problems. Because if you improve just one problem, okay, it's true, the LCP score will be impacted, but it will be not impacted in an optimal way. So to impact the LCP score in an optimal way, you have to improve all the problems. So if you want to debug LCP problems, it's easy. Open the Chrome DevTools and go to the performance panel. But performance panel is quite complicated to understand if you are not familiar with this panel because there is a lot of noise into it. And that's why Google launched a new experimental panel called Performance in Style. This panel is a new modern performance panel which gives you exactly the same schema I have presented in my slides and give you a lot of links to help you to debug a LCP problem or to debug web performance problems. These links are following the documentation. If you want to understand how to split correctly your content, you can use the coverage tool. This tool will be your best friend. And in this picture, you can see there are two colors, the red one and the blue one. The red one corresponds to the unused parts of the file, and the blue part corresponds to the used file. So now, let's go to the cumul layout shift matrix. CLS measures the instability of content by summing shift scores across layout shifts that don't occur within 500 milliseconds of user input. This definition is quite complex, but in other words, CLS metrics represent the stability of your screen, the times before the screen is stable for the users. So if the score is less than 0.1 seconds, your score is good. Between 0.1 seconds and 0.25 seconds, your score needs improvements. But don't worry, it's just images that have maybe no measures or no high, I don't know. But above 0.25 seconds, all the architecture of your index.html page need to be reviewed. So what can cause cumul layout shift problems? First, image. Image with no size, image with bad size, image with a not correct ratio, dynamically injected content. It's easy to have these problems because thanks to Angular, React, or Vue, it's easy to hide or show something dynamically, right? So be careful when you use it. Waiting network before updates, DOM. So it's easy to have these problems. If you don't want to have these problems, go on server-side rendering frameworks maybe. Add embeds iframe can cause cumul shift problems. And finally, my favorite, web fonts. Web fonts, if the web fonts, it's not because the web fonts have the same size that renders the same way. So in this picture, in this slide, you can see how image have an impact on CLS problems. And in this video, you can see how iframes have an impact on CLS. So something pop randomly on the screen and the screen shifts downward. And at this particular moment, the user loses his reading focus. So to avoid sites, this is my tips. First, size correctly your image, thanks to the high width attributes. You can also use the aspect ratio, new property CSS. For add, embed, and iframe, which have a dynamic content, don't put them on the top of your page. Put them on the right, on the left, on the bottom, but not on the top, because when the iframe pop on the screen, automatically the screen shifts downwarded and the user will lose his reading focus. For add, embed, and iframe that have static space, it's quite easy to solve this problem. Just reserve the space into your HTML documents and all will be good. And finally, size correctly your fonts. Adjust the size of the font with the new property CSS font adjust. So if you want to debug a CLS problems, is easy too. Go to the DevTools and run a lighthouse audit. Lighthouse is a powerful tool which can give you a lot of information about your application, which give you a lot of explanation of how to debug some problems of performance, problem of SEO, and other problems. Just a few words about Lighthouse. In Chrome 103, Lighthouse have two new modes. So the first mode is navigation. This is a previous mode, in fact. All the audits you run before Chrome 103 are considered as a navigation audit. Navigation audit is just an audit on a single page loaded. But now, in Chrome 103, the two new modes are the time span mode. Time span mode is an audit on a range of times, generally containing few user interaction. And the last mode is snapshots. Snapshots give you the possibility to have an audit on a specific time, specific state of your application, generally after a user interaction. The last metric is FID, first input delay. So FID is a metric that captures the user first impression of a site's interactivity and responsiveness. In other words, the FID measures the times between when the user clicks on the button and when the first line of the JavaScript code assimilated to this interaction is executed. So if your FID score is less than 100 milliseconds, your FID score is good. Between 100 milliseconds and 300 milliseconds, your FID score needs improvements, but don't worry, it's just few JavaScript to rework. But above 300 milliseconds, your score is very bad and all your JavaScript needs to be reviewed. Sorry for that. So what can cause FID problems? Two things, main thread blocked and useless JavaScript. As you know, in JavaScript, we have just one thread. So to make an asynchronous programmation possible, we created the event loop, right? So now imagine we have a lot of interaction with our application. User interact a lot, so a lot of interaction is on the task queue. So at the moment when the user clicks on other buttons, the action behind this interaction is added at the end of the task queue. And all the events in the task queue before the last task have to be executed. So at this moment, we said the main thread is blocked. And the last one is useless JavaScript. Useless JavaScript, it's okay, you have an application that have a lot of life. And imagine a lot of JavaScript are not used. It's easy to solve, remove it. It's not because JavaScript is not executed that the JavaScript is not parsed. So how to improve some FID problems? First, split JavaScript. Avoid long task or breakup. Then, lazy load. Lazy load feature and piece of code. Okay, it's now very easy to do that. Thanks to the frameworks, you can lazy load easily your feature, so abuse it. And thanks to ECMAScript and ECMA module, you can lazy load some piece of your JavaScript code, so do it. Optimize. Avoid waterfall fetch required or third-party scripts. Okay, as I said, generally application we create every day are client-side application. Okay, so if you have a lot of third-party script, the main JavaScript file will be huge. And if it's huge, it will take a lot of time before the user can interact with the application also. Right? If you want to use third-party scripts, things to use lightweight third-party scripts. So instead of using moment.js for managing date, use datefns library. Okay? And finally, delegate. Use a web worker to avoid blocking the main thread. Sometimes on the front-end side, we have a huge business to do. Okay? So if you do that on the main thread will be blocked. So the idea behind, if you have a huge business to do, delegate to a web worker. The web worker is present to do that. When the work is done, web worker will notify your main thread and you can do all what you want with this notification. So INP. INP is a metric that aims to represent a page's overall interaction latency by selecting one of the single longest interactions that occurs when a user visits a page. So in other words, the INP matrix is the times when the user clicks on the button and when the next frame is painted to the users. Okay? What is important to understand is INP is still in pending status. So it's not totally integrated into the Core Web Vitals. It will be integrated in 2024. Okay? INP score, if the INP score is less than 200 milliseconds, your INP score is good. Between 200 milliseconds and 500 milliseconds, your INP score needs improvements. But as the FID problems at this moment, it's just some JavaScript to rework. But above 500 milliseconds, your INP score is very bad and all the JavaScript needs to be reviewed. So a little word about INP. INP can be easily assimilated to long task in JavaScript. So to avoid long task to JavaScript, it's quite easy. Promesify all your JavaScript, use yield JavaScript. And my little tips about optimizing the INP is, if you know you have big actions, just display a loading. Okay? So I have a little time for a demo, and I would like to present you some tools, developer tools I show you in this talk. So this is my application. It's a very easy application, to be honest. It's just displaying some products. You can add it into the basket when you click on it. Sorry. Sorry. Okay. Normally it works, but I have some problems with sharing my screen. So you can add it, you can filter the products, etc. So sorry, it will be complicated with my sharing. Sorry. So here's the performance inside panel tool. Okay, I have mandatory to rework. So you can see we have the previous schema we add in the slide. So we can find here in blue, it's the main HTML, the main index HTML file. So it's the initial HTML documents. Here you can find I have no problem with my LCP. My LCP is correct. Okay, you can see it. You can see here. Okay. Sorry, it's complicated with the Zoom. I can't show the demo. Oh, okay. So here you can see the FCP time to interaction and LCP is in grid. So I have no problem with my Core Web Vitals. Okay. Here in this panel, you can see the links to the documentation. Okay, it's a Google documentation. So if you have problems, you will have some links here too to go to the official documentation. Sorry for that. Okay, now I will show you a Lighthouse report. So you can go to the panel. It will analyze all your application and give you a score. Okay, so in my application, I have some problems. So I respect all the best practice, but I have some performance issues. I have some accessibility issues. And if you go, I respect all the Core Web Vitals, but you can see that in my accessibility, I have some image that don't have the alt attributes or something like that. So all your problems will be detailed in this panel. Okay? Thank you. Thanks for your attention. And sorry for the bad demo and my bad English accent. I'm French and it's quite complicated to speak in English. But thank you a lot. Thank you for coming. You can follow me on social networks with LinkedIn, Nicolas Frizzarin, or on Twitters with @Nikos54. And thanks again. And have a great day and learn a lot of things through the future talks.